During this demo, I would like to show and explain StreamX mesh scaling and resilience together with processing and delivery layers decoupling. Let's start with scaling. In general, StreamX mesh pipeline scaling is as easy as Kubernetes deployment replicas number change. Depending on the expectations, we can scale the mesh on the processing layer or delivery layer. Looking at the processing services characteristics, you can find that those are using shared subscriptions to read the data from the channel. That means each message is read and processed only by one service replica. So if you want to, if you have a big volume of the data on the channel and you want to process it faster, then you can add another replica of the processing service. On the other hand, the delivery services are using exclusive subscription to read the messages from the channel. That means that each replica of the delivery service is reading all the data from all the messages from the channel and then exposes those to the end user. So if you would like to handle more requests from end users, then you should add more replicas of delivery service. Let's take a look on the demo. I will use Locus tool to generate a load on web delivery service to observe how many requests per second it can handle. To generate load for this test, I am using a cluster of 44 nodes. Let's start the test. We will be requesting for block HTML page. Currently, we are using only one replica of delivery web service, and let's wait a while and check how many requests per second it can handle. It looks like it's stable, 20,000 of requests per second. And here you can see the latency, the response times, and it is pretty low, 6 milliseconds and 15 milliseconds. So now I will go to GCP console. This is the page for our delivery service, the web delivery service. Here you can see that we really are using only one replica. And now I will change the replicas number to 3. It will take a few seconds for StreamX to init a new replicas because it has to pull the image, start the container, and recreate the current state of the data by reading all the messages from compacted channel. When the state of that replica will be exactly the same as already running replicas, StreamX will mark this instance as ready to serve responses. Let's switch back to the Locus, and as you can see, those replicas are already up and running. And currently, our delivery service is able to handle 41,000 requests per second, and still the response times are pretty low. Okay, so now I will go back to the console and I will delete one of the replicas in a way that will emulate a crash of this replica. And let's see what will happen. You can see the request per second decreased, but in the background, StreamX is already initializing a new replica with the current state of data, and when it will be ready, it will start handling the requests. And this is what we can observe right now. And this is the resilience of the StreamX mesh. Yeah, and going back to the scaling, as I said, it is easy as changing the replicas number of the Kubernetes deployment. I showed you the delivery service scaling, but the same process applies for the processing services. And it does not require any additional configuration, any setup. It just works. Taking opportunity that we have this test running and our delivery layer is swarmed with the requests, I will show you how StreamX delivery and processing layers are decoupled. This is the page that Locus is requesting for. Yeah, you can see this title. Now I will go to the CMS and I will change this title, and let's see how long it will take for StreamX to process that change. Save, publish, refresh. Yeah, it's there. As you can see, it was pretty fast, but with Jagger tool, we can exactly check how long it took for StreamX to process that message. Here is the trace for that publication request. It was done a few seconds ago, and it took like 33 milliseconds to process from the ingestion to the delivery this publication. And if I open it, you can see how long it took for individual services to process that message. Yeah, that's it for today. Thank you for your attention. Bye.